Hello guys, this is the second tutorial which belongs to 6.3. Right, in this tutorial we are going to learn two things. One is called multiplexing and the other one is called encoding. In there you have to learn few techniques in their use. Right, so the first of all, let's see what is multiplexing. For that purpose I will explain you using this diagram. Think this is device X, which is use some type of transmission media like you learned in the previous sessions. Then you have the clear idea about transmission medias. So this is also device Y or a device Z. So whatever it is, a number of devices are connecting for the main tower or a main place through using various type of transmission medias, and in there they are transmitting signals to the other tower or other main important place using single transmission media. So in there multiplexing is occurred. That means the signal related to several devices. In here X is sending a signal related to X and Y is sending a signal related to Y, and those two are combining each other. Then X and Y signals are transmitting through this single transmission media, and the receiver's end in there they have to release all the signals for a particular device. Then X is sending X signals to the device called X dash, and Y is sending Y signals to the device called Y dash. So that's why the signal related to several devices that are received through the several transmission media are transmitted through a single transmission media, and transmitting from one place to several other places actually. So few examples, or a few telephone messages can be transmitted simultaneously at the same time. Using one single transmission media we can transmit few type of messages, right, in a transmission media. So that is simply called multiplexing. When we talk about multiplexing, there are few types. Mainly multiplexing can be categorized into two parts. Let's see what are they. We know there are two type of signals that we learned in previous part. If you don't know about two type of signals, please go watch my previous videos. And in here there are two types of signals that we have. One is called analog signal. Right, analog signals are used to transmit analog data or analog data. And digital signal, it's like ones and zeros. They're using ones and zeros. They are creating these type of signals. These are called digital signal. Right, each and every electronic devices that they use digital signals instead of analog. In here, when you are talking about analog signals are categorized into two parts when they are doing their multiplexing parts. One is called FDM or a frequency division multiplexing, and the other one or other part is called WDM, that means wave division multiplexing. There are two type of things that we have to use with the analog signals. And digital means, or digital, when you talk about digital signals, then I have shown some diagram in here. Then digital signals, or it can be time division multiplexing, it's one part. Then I will explain what is that. Right, let's see one by one. In here, what is FDM or a frequency division multiplexing with the analog signals. In here, the bandwidth, you know, the bandwidth is that the width of the pipe, right? It is changing. The bandwidth is like this. It's a width of the pipe, and this is X, and if this is Y, right? When we are talking about bandwidth, then X bandwidth is higher than the Y's bandwidth, right? So the bandwidth is shared through the communication channel. If you are using FDM or a frequency division multiplexing, in there few users are allowed to send their data using single communication medium, so broadcasting not through the air. In here they are using physical paths to transmit data, and frequency division multiplexing or FDM, then you can get some clear understanding in here. So many signals can be transmitted at the same time. So these are the advantages of FDM. Then look at in here, there are one type of signal. The shape is different from this one, and another shape is here. But these are analog signals. In here, when they are modulating signals, when they are creating the modulated signal, right? So they are sending, right, these signals and these signals and these signals through the transmission media. After combining those things, after getting and mixing those things as one, they are sending through the transmission media. So many signals can be transmitted at the same time. That is also the advantage of FDM. Another one, and the other one is synchronization is not necessary. Synchronization means when you are sending one message to the other, when you are saying something, some person to hello, then that person will say you hello back. That is called the acknowledgement, or he will say then he heard your hello and he will respond to you, I have received your message, and that is simply called synchronization. With the FDM, synchronization is not necessary. So only a single channel get affected due to so narrow band failure. So that's another advantage. Right, let's move to the next slide. In here, wave division multiplexing methodology, or a WDM. This technique is used in fiber optic transmission. Right, WDM used with the fiber optic data transmission. So we know in fiber optic cables, then we are not using electronic waves. In their way, we are using some type of light waves, which is transmitted through the fiber optic cables. Right, then you can see, right? So the bandwidth is divided logically. That means you know what is bandwidth. It is divided logically, and they are transmitted into channels. So channels are used, and paving the way to transmit data to each device through those channels. And so devices are able to use channel independently. So when they are using some type of channels, it's like radio channels, 99.5 like that, it's 99.6 like that. There are two different channels they use when they are transmitting signals using WDM multiplexing technology. I think it is clear for you. So this is the part of the picture. They are changing, or they are dividing, so the logical, and they are transmitted into channels, or the bandwidth is divided like this. Right, this is the shape of the WDM. And the next part is called time division multiplexing. So you know the time division multiplexing is used with the digital signals. That we know what is digital signal. So all the signals are not transmitted simultaneously. In here, they are not transmitting signals simultaneously. At the same time, they are not transmitted signals, but transmitted one by one. So that means one is passing, and the second one is passing, and third one is passing, like that, transmitting one by one. So division of time among the devices. In here, they are giving some times to transmit data for the device, for the particular device, to the transmission media, and letting them to use the transmission media commonly is done. In here, I will say sometimes, once again, so division of time among the devices, so you have a device called A and another device called B, right? So this is 1 second, and this is the second second. Second is used to transmit B's data, and 1 second is used to transmit A's data, and then third second is here. So and third second is here, fourth second is here. They are giving the time. So that is called time division multiplexing methodology, or a TDM. That means all the signals are not transmitted simultaneously. They are not transmitted simultaneously like you did in the previous part, but transmitted one by one. I think this is clear for you. In there, very especially remember, the time is dividing part, division of time among the devices connected to the transmission media. and letting them to use their transmission media commonly is done. And what is data synchronization? I have told you one person is saying you hello, that the second person will respond to you hello. That means he heard that one. It's a similar thing. So synchronization is used to ensure that the data stream are received and transmitted correctly between two devices when they are transmitting data for the one device 1, E and B, right? When I send you some ball, right, then catch the ball and we'll say I caught the ball properly. And that is the similar things for a synchronization. Usually a clock signal is transmitted in sequence with a data stream to maintain proper signal timing. I think that is all. Now what is data encoding? Here we are going to learn then what is data encoding. And the previous part we learned three things, or an analog signal and the digital signal. In digital signals we use the time division multiplexing, and in there we use two type of things. So when analog or digital data are transmitted one place to another, they are converted as well. Then we know it. So we have digital data like this, right? So if you want to transmit this data through the transmission media, you cannot do it as data. But if you converted this data as signals by using any mechanism, that is called encoding. Low voltage places, high voltage places, low voltage and high voltage places. You are drawing this diagram, then this is called digital signal, right? This conversion process is called encoding. What is that conversion process? Analog or digital data is converted as what? Signals. That is called encoding. So when you talk about encoding, there are few conversion techniques. The one is called non-return zero level, or a simple form NRZL. And the second one, non-return zero inverted, that means NRZI, that's the second one. And last one is called Manchester encoding. Let's learn one by one. Here, then what is non-return zero level? In here you can see there are some digital data, right? When they are marking the low voltage places and the high voltage places. In here you have to remember one thing, very special thing. The places of 0 are converted as high voltage. This place belongs to 0 and this one is 0, this one is 0. When they are marking those things, they are marking those zeros as high voltage, right? So this one is okay, and these two zeros are considered as high voltage places. These three zeros are, and these ones as considered as low voltage places, right? So after creating those things, then you can see the original signal like this. Then that is called non-return zero level, right? That is the part of the data encoding. And non-return zero I means, or when the signal is converted. In here you can think 1 1 0 0 1 1, right? The places of 0 are converted as low voltage. In here the places of 0, if it is 0, this is called low voltage, and these places we can call high voltage. After getting those things, you can create a signal. It's low voltage, high voltage, and low voltage and high voltage. You can draw your diagram. I think this is wrong, and this one, because those are low voltage places, right? So these are the places which is belongs to low voltage, and this is belongs to high voltage. So I think that is clear for you. Next, lastly, we are going to talk about the Manchester encoding, right? That is of the part of the encoding. Division of time. In here they are dividing of time required for a transmission. In here of one bit into two similar parts. One bit into two similar parts. In here you can see one bit, it's 1. It is divided into two similar parts. Look at it, right? So one bit is divided into two similar parts and carrying out encoding process, right? This is called Manchester encoding in their time required for transmission of one bit into two similar parts. That's all. Then what is parity check? The parity check means, I have taught you what is synchronization, right? In there they are checking some parity. This is also simple error detection mechanism when you are sending some message to your girlfriend or when you are sending some message to your boyfriend, right? In there they will respond you, but your device must recognize your friend watched or your friend have seen it. Then you have to get some proof it is sent, it is sent to the particular user or receiver. This is also a simple error detection mechanism actually. So extra data is added when you are transmitting some data value. You are adding another thing. This is called extra value. There are two types of techniques. This bit is called, if you are adding some type of binary digits, either 1 or 0, that is called parity bit. When you are transmitting some original data or as an original signal, you are adding another extra bits to recognize that one, that is called parity bit. Normally data encoding process is used 7 bits as mentioned ASCII. Parity bit is the extra one. The 7 bits are used in data encoding techniques. Extra one is the parity bit. There are two types of parity checks. One is called even parity and the other one is odd parity. Let's see one by one. In here you can see the diagram. So this is the letter and decimal values belongs to this one, and this is the ASCII code for 83. If you don't forget it, if you don't remember that part, please try to solve this one, right? So 83 is divided by 2 like that, then you know how to get it, right? And this is the transmission data. Then parity bit must be it's 4 bits are there. That's why you have to additionally add 0 in here. Then parity is even, it is equal as 4. And the other one is C, it belongs to this one, and there are 3 ones in here. Then look at it carefully. That is odd part. Then if you want to send even parity, then you are adding another one to the front of the number, and it is sent to the particular organization or institution. So this is called even parity. In there we are keeping a number of ones as even. In here it's odd parity, means when you are sending or when you are transmitting data in between two places, we are keeping our number of ones as odd. And look at this example, 64 is like this. In here then 1 is odd, then you have to add additional 0 to the front of the number, right? Then number, there are 7 numbers used ASCII, and additional one is called S0. In here 65, then you have 2 ones, that's why no need to add any one in here, right? It is also even one, that's why you have to add another one to the front of the number, and this methodology is called odd parity. And after explaining this even and odd parity, I'll stop this video. Let's meet on 6.4 video, and don't miss the video, and join with my channel and subscribe it if necessary, and help me to subscribe this one. And you have to guess some things, and after explaining all the networking parts, I hope to do any past paper questions with you, and you can join with me. Have a nice day. Bye. Thank you.